Okay, guys, so today we are going to finish our discussion of chi-square test for goodness of fit. And the last piece that we have not yet talked about is making that final conclusion. And that's a really easy one because it's exactly what we've been doing with our z-tests and our p-tests. So we always set a level of significance. If our p-value is less than that level of significance, we reject the null in favor of the alternate. And if it's greater than that level of significance, then we fail to reject the null hypothesis. And so today we're just going to run together two complete tests or chi-square tests for goodness of fit, and then you'll have one to do for practice. So this first one says a company claims that each batch of its deluxe mixed nuts contains 52% cashews, 27% almonds, 13% macadamia nuts, and 8% Brazil nuts. To test this claim, a quality control inspector takes a random sample of 150 nuts from the latest batch and finds the following. So here we've got their data out of the 150 nuts. They also set a 0.05 level of significance. So our parameter here is the types of, or the percent of nuts for each type. So then the null hypothesis would say the claimed distribution of types of nuts is correct. And then this next one would say it's incorrect, so I save myself some time. Copy and paste. Make sure that's incorrect. Right, it gave us that our level of significance was 0.5. And so now our two conditions, remember that's 3. I should have changed this in our notes. Yours, I maybe will go back and change before I post them. So our third condition, our first is random. So in this case, they took a random sample of 150 nuts. The second one is large counts. All right, and so up here, let's find our expected counts. Right, it said 52% of our samples should be cashews. So I'm going to do 52% of 150. 150 times 0.52. We would have expected 78 to be cashews. 27% almonds, so 0.27 times 150 is 40.5 almonds expected. Our macadamias were 13%, so 19.5 macadamias. Oh, we got pretty close there. And then the Brazil nuts, 8%, so 0.08 times 150 tells me we expected 12. All right, all of those are greater than or equal to 5, so our large counts condition is met because all expected counts are equal to 5. And then that last one, independent. This is true because our sample of 150 nuts is definitely less than 10% of all mixed nuts. All right, now we find our test statistic. Remember, that's a chi-square value. And that's where we do the observed, 83, minus expected, squared over expected. 29 minus 40.5, that one was way off. 20 minus 19.5. And 18 minus 12. All right, so now I'll do a little calculator work if you guys need to write that down. 20 minus 19.5 squared. Okay, so I'm getting 6.5988. All right, so then our p-value, remember we have our degrees of freedom equal to 1 minus our categories. We have 4 categories, so 3 degrees of freedom. So now chi-squared CDF would be, from our test statistic, 6.5988. Remember, we would technically be shading to the right, so all the way up to 1,000 with 3 degrees of freedom. 6.5988. I get 0.0858. All right, and now that is greater than our test or our level of significance, 0.05. So we fail to reject. So that says we do not have enough evidence to say that their claimed breakdown of each type of nut is incorrect. All right, so we have an inconclusive test. Maybe we would rerun it or find new samples to test. Okay, here's the second one. The manager of a high school cafeteria is planning to offer several new types of food for student lunches in the following school year. She wants to know if each type will be equally popular. To find out, she takes a random sample of 100 students and asks them, which type of food do you prefer? Asian, Italian, Mexican, or Greek? She uses her results below to run a chi-square test using a 10% or 0.10 level of significance. So if each of these categories is equally represented, and there are 4 categories, then we would expect 25 students to be in each category. If they're equally represented, that would be our expectation, right? And so our null hypothesis here will say that the types of food are equally preferred among students, or something along those lines, right? You could say the distribution of types is all equal, or every type is represented equally. You could say that in a variety of ways. HA will say the exact same thing. So again, I'm going to cut this. Oh my goodness. Oh my gosh, you guys, I'm sorry. Oops, up here. Okay, now we got it. Jeez, oh Pete. Unequal. Preferred. All right, our level of significance alpha was 0.10. Our 3 conditions, this was a random sample, it says so. She took a random sample of 100. Large counts is satisfied because all expected counts are greater than or equal to 5. And then independent is our third one. It is checked off because 100 students. We don't know how large the school is, but we would guess it's a high school, so we would say it's less than 10% of all students. All right, now we do our chi-square test statistic. So we'll do observed minus expected squared over expected. 22 minus 25 squared over 25. 39 minus 25 squared and 21. Okay, so I'm gonna do 18 minus 25 squared over 25 plus and I get 10.8 as my test statistic. All right, now we do our p-values. So our we do chi-squared CDF from that test statistic up to 1,000 with how many categories? 4 categories, so 3 degrees of freedom. Second vars, chi-squared CDF. We get 0.0128. That is absolutely less than 0.10. And so we are able to reject the null in favor of the alternate. What does that mean? That means the types of food are not equally popular. Okay. Alrighty, so there we've got our 2 examples. One where we were checking to see if the categories are equally distributed, and one where we were checking to see if the categories are represented correctly based on the claimed percentages given to us. All right, see what you can do on the practice. And then I think you're getting ready for a quiz. So I hope you do well.